welcome to the Chapter 2 review questions. As always, when I do the review questions, I'm not going to be doing question number 1 because it is a lot of terms and definitions, and you can look those up in the glossary or in the chapter by yourself. But question number 2 actually has, I think, 8 parts. I only wrote the first 4 on the board. But it gives you a lot of types of matter, and it wants us to classify them as an element, a compound, a heterogeneous mixture, or a homogeneous mixture. So part A says a bowl of fruit and yogurt. Well, this is not an element. This is actually a mixture, and this is a mixture that I can see all the different parts in, and it is not the same throughout. So we call this a heterogeneous mixture. Letter B is a sample of helium gas, which cannot be broken down. Well, helium, if it can't be broken down, I know that it is an element. And if you look on your periodic table, you will see helium as the second element. C, sugar dissolved in water. Well, so this is a mixture. I have multiple things mixed together, sugar and water. And so, but if I have sugar and it says it's thoroughly dissolved in water, this is going to be a mixture that is the same throughout. And so this is considered a homogeneous mixture. D says baking soda, a compound of baking soda, but it can be broken down, and it tells me it can be broken down into hydrogen, carbon, oxygen, and sodium. And so if it can be broken down, but it's not a mixture, it's a compound. So how I know it's not a mixture is it's not multiple stuff. It's one thing, it's baking soda. But it's not an element because it can be broken down into these different parts. The second part of question number 2, we're still classifying matter, and E and F go together, but it's grams of magnesium, which is one of the 2 simplest substances produced when magnesium oxide breaks down. And then G is magnesium oxide from above. So we have magnesium oxide, and we can break it down into magnesium and oxygen. And so E is asking for that magnesium. Well, if this magnesium is the simplest substance and it can't be broken down anymore, it is an element, and you will find it on your periodic table. F, magnesium oxide from above. It's not an element because it's multiple elements together, right? Magnesium and oxygen. So this is just a compound. And G, we have a strawberry. And so on a strawberry, there's a lot of stuff in a strawberry. But if I look at a strawberry, is it consistent throughout the strawberry? And the answer is no. You can see the seeds on the outside, and sometimes you can see the little green on the top. So it's not the same throughout. So it is considered a heterogeneous mixture. And H, we have a cup of tea with no leaves in it, just the liquid. If you ever look at a cup of tea without the leaves in it, it looks the same throughout the whole cup. So it is a homogeneous mixture. Question 3 tells me a student's doing a chemical reaction with 2 different chemicals, and these 2 chemicals have a total mass starting out of 45 grams. When she's done with the reaction, she finds the mass to be 34.5 grams. Has she collected all of the product? Well, if I start off with 45 grams and I end with 34.5, I know the law of conservation of mass tells me that mass cannot be created nor destroyed. So I have to, if I start with 45 grams, I have to end with 45 grams. And so she has not collected all of the product. Some of it could have escaped in a gas and not have been able to have collected it, but it was there. She just didn't collect it all. Question number 4 refers back to question number 3, and it's asking what is the mass of the product that was not collected. And so to figure that out, I'm going to take 45 because I started with 45 grams and I ended up with 34.5 grams. And you're going to do subtraction, and that will tell you the mass that was lost. You should get 10.5 grams. Now, you're doing subtraction with significant figures, and so you're going to report your answer to the least precise measurement. Both of these measurements are measured to the 10th of a gram, and so your measurement or your answer is going to be to the 10th of a gram. Question number 5 says that water can be broken down into hydrogen and oxygen gas. This is actually a fun experiment. You just use a battery and you do what's called electrolysis. You may have done this before. But if I have a mixture of hydrogen gas and a mixture of oxygen gas, they behave nothing like water. Well, at room temperature, water is a liquid. But if I take hydrogen gas and oxygen gas at room temperature and mix them together, I have a gas, and that is nothing like water. And why is this the case? Well, in water, we have a compound of H2O. But in this mixture of hydrogen gas, we have floating around individual hydrogen molecules, and hydrogen is one of these compounds that doesn't like to be alone, so I'm going to put the 2 there. And we also have oxygen compounds, and oxygen always likes a buddy. And so we have mixture of these gas and this gas mixed together, but it hasn't formed a compound. This happens because in a mixture, the components keep their own individual properties. But when they combine to make a compound, they get new properties, or they have their own separate properties as a compound. Question number 6 tells me you have a 750 gram sample of a white powder, and we're breaking it down into its parts, and we end up with 29.86 grams of copper, 15.06 grams of sulfur, and some unknown quantity of oxygen gas. And question A says how much oxygen was made. So for this problem, you're going to use the law of conservation of mass. And we know that if we start with 75 grams, we have to end with 75 grams. So you're simply going to take 75 and you're going to subtract 29.86 and 15.06. And when you do that, you're going to end up with 30.1 grams. I only have 3 significant figures in my answer because I am going to be reporting to the least precise measurement since I am adding and subtracting, and my least precise measurement is to the tenths of a decimal place. So part B is telling me instead of making 75 grams of this powder, I only want to make 11.2 grams of this powder, and I don't want any leftovers. So I need to find the ratio of comparing 11.2 to 75. So I know like my multiplication factor to see if I'm doubling the recipe. Actually, in this case, I'm going from 75 to 11. So are you halving the recipe? Am I dividing it by tenths? What exactly is the multiplication factor that I'm doing? So I'm going to do that by saying now I'm going to make a multiplication factor here. I'm going to put 11.2 over the 75. The reason I put 11.2 over the 75 is I'm going to actually, when I do this, end up with a small number. This is my multiplication factor. If I put 75 on the top, I would end up with a really large number. And I know that 11.2 is less. And so I'm actually going to be making like a percentage or a smaller number. I'm not making more of it. And so I'm going to put the 11.2 on the top. And you get a multiplication factor of 0.149. Then it asks how much copper, sulfur, and oxygen would you have? And so I have 0.149 as my multiplication factor. So you're going to take for copper, it's 29.86 grams times 0.149. You're going to take, for copper, you take the base amount and you multiply it by the multiplication factor, and you do the same for sulfur, the 15.06, and for the oxygen, and you should get 4.45 grams of copper, 2.24 grams of sulfur, and 4.48 grams of oxygen. And these are all smaller numbers than we started with, and that is the case because we're only wanting a total of 11.2. And so if you add them all up, you should get really close to 11.2. Question number 7 is telling me that a chemist is making 86.94 grams of a black powder. And they're doing that by reacting 54.94 grams of manganese and 32 grams of oxygen. So we've got our manganese and we mix it to oxygen and we get 86 grams of black powder. Now the second part of this reaction is the chemist actually takes more than 86 grams. So either they made more or they had more of it. and they are taking 144.9 grams of this black powder, and they are breaking it down. So instead of making it this time, they're taking it apart, and we're looking for how many grams of oxygen we have and how many grams of manganese. I'm going to write Mn because that's the chemical formula for manganese. And so we're going to be doing what we were just doing, and we're finding a multiplication factor or a ratio to go from 86.94 grams to 144.9 grams. Now, I am going to a bigger number. I am multiplying this by some number greater than 1 to get 144.9. So I'm going to say 144.9 grams, and I'm going to divide this by 86.94 grams. And this will get me this multiplication factor. And I get 1.667. I'm going to have 4 significant figures because all of my measurements there have 4 significant figures. So now you are going to take 54.94 and multiply it by your multiplication factor to get that. So 54.94 times 1.667 is going to give you your grams of magnesium. You're going to do the same thing for oxygen, 30. So the grams of magnesium is 91.58, and for oxygen, 53.34. I know my decimals are hard to see sometimes. Question number 8 is taking some of the information from question number 7. So I rewrote the original part of the part for question number 7, where we have magnesium and oxygen and we're making a black powder. It then gives you a different recipe to make a powder, and it is 7.85 grams of magnesium and 2.9 grams of oxygen. And the question is asking, is this the same compound as in question number 7? So to compare the two, we have to write a ratio and see if these are reacting in the same ratio. Now there's many ways that you can write a ratio. You may compare them differently, but I'm going to do magnesium to oxygen. And so for the first one, if I did magnesium to oxygen, on the first one, I get a ratio of 1.717. So this is for this one. So let's do the same thing for the second equation. And you get 3.43. And so they are not reacting in the same ratio. This one, there's far more magnesium to oxygen as there is in the first. So these are different formulas or different compounds. All right, so for question number 9, I am leaving the part from question 7 up because we're going to use it again. And it gives me another experiment that a chemist does. This time it's telling me they're taking 10 grams of magnesium or manganese, and they're mixing it with 5.8 grams of oxygen. And they're asking, is it the same compound as in number 7? So as you did in the last one, we did magnesium over oxygen. And for number 7, just rewriting it, I got a ratio of 1.717. By number 7, I mean this is the equation from question number 7. And now for this one for question number 9, I get 1.7. And so these ratios are essentially the same. And so this is the same compound. Question number 10 says to write down all 4 parts of Dalton's atomic theory. Didn't really want to do it, but I did it, so I hope you do it too. Part 1 is all matter is made up of atoms, which are indestructible and indivisible. Part 2 is all atoms of an element are identical in all their properties. Number 3, compounds are formed by a combination of 2 or more different atoms. And part 4, a chemical reaction, this is a frequent shorthand way of writing reaction, is a rearrangement of the atoms that exist in the substances which are reacting. Dalton's theories are really close to being accurate, but they're not 100%. So question 11 tells you to note anything that is incorrect with the propositions from question number 10. And so proposition number 1, it says that all matter of atoms are indestructible and indivisible. Well, we actually know that we can destroy atoms. You're going to learn later about nuclear reactions and nuclear decay. And we can actually split atoms. We have a whole big machine in Europe called the collider that can split atoms. And so they are destructible and they are divisible. The other one that there is something, so that part is technically incorrect. Number 2 is that atoms of an element all are identical in all their properties. And we've learned that that isn't true because atoms of an element can actually have something called an isotope where it has more neutrons in it. And by making that atom fat or heavy, by adding a lot of neutrons, we actually can change some of the properties of the atom. Question number 12 is a bit confusing just to figure out what you're trying to do. But it says a chemist makes 2 different compounds from the same 2 elements, tin and chlorine. And if you don't know, the chemical symbol for tin is actually SN, so it's kind of confusing sometimes. So the first one, he uses 50 grams of tin and 29.87 grams of chlorine. There's no leftovers. And then he does this reaction again with 50 grams of tin and 59.74 grams of chlorine. And there are no leftovers. And so in this first reaction, we know that there are 2 chlorine atoms in this compound. This is some compound with tin and chlorine in it. It could look something like this. Would be if you were to try to write it out. Now, this one, we don't know how many chlorine or atoms are in it, and it's wanting us to figure that out. And so we're going to try and set up a ratio here to figure this out. Now, I know that both of these, I have the same amount of tin. I have 50 grams of tin in both. So I want to figure out what is happening between the chlorine. So I'm going to compare 59.74 grams on the second one to 29.87 grams of chlorine. This actually equals 2. So I know that the second equation has twice the number of chlorines. So when this one has 2 chlorines, this one must have 4. Number 13 tells me a chemist is making 2 different compounds in 2 different reactions, but they're using the same elements. We're using nitrogen and oxygen. And the first time we're using 10 grams of nitrogen and 11.42 grams of oxygen. It doesn't tell you what the gas is. It just says you're producing 21.42 grams of a gas. Now, the next time the chemist is wanting to make a totally different compound, and they're taking 10 grams of nitrogen and some number of oxygen, and they're going to end up with no leftovers at the end of the reaction. And they give you an option of like ones that you can choose of how many grams of oxygen. Now, we just did a bunch of ratios, and the purpose of doing like in the last problem is we found that it was a multiplication factor of 2. And so we need to remember that these react in small whole number ratios. And so if nitrogen stays the same, I need to be able to multiply 11.42 by some small whole number ratio to get this next number, because this is like the base ratio for nitrogen and oxygen. Well, 11.42 is not like the only one of these that it could possibly be is 22.84. And the reason I say that is if I have 11.42 and I multiply it by 2, I get 22.84. And so this is referring back to the law of multiple proportions that says that the fixed mass of one of the elements, the masses of the other elements must react in small whole number ratios. And so this is a fixed mass of one of the elements. And so the next element must react in a ratio. And so none of these other choices is a ratio of 11.42. You would, if you used one of these other 2, we would have some leftovers, and the problem says there's no leftovers. Number 14 is pretty simple. It says what 3 particles make up an atom, and it is the positive proton, the negative electron, and the neutrally charged neutron. And these are the three particles that make up an atom. Question number 15 says to give the charge for each of these. And so I just said a proton is positive, electron is negative, and a neutron, we just say it's neutral. It doesn't have a charge. Question number 16 refers to that plum pudding that I have never had before, and it wants us to describe the plum pudding model, and always gives you a picture of something like this, and there's positive charges throughout, and then there are negative charges. These are the electrons, so like the bread is the positive charge, and this is the negative charge. And what experiment demonstrated that it wasn't correct? And that is Rutherford's gold foil experiment. Number 17 says to describe the planetary model of an atom. You can either write it in words or you can describe it, but it's got these positive charges in a nucleus, and there's some neutrons there, and your negative charges orbit around it, kind of like planets going around the sun. And the person who proposed it was Rutherford. Remember, Rutherford is who disproved the plum pudding model, and this was his proposition. Question 18 says that one of the three particles that make up atoms, protons, neutrons, and electrons, there is actually one particle that does not appear in some hydrogen atoms. What is it? Well, what makes a hydrogen atom is it has one proton in the middle. If it didn't have that one proton, it's not a hydrogen atom. And so to go with that proton charge, there is one electron. So question number 18 is the hydrogen atom does not have a neutron. Question number 19 gives me the particles that are in 4 atoms, and it asks me what 2 atoms are going to be isotopes of each other. Now, isotopes are of the same element, so therefore they have the same number of protons, but different number of neutrons. So the only 2 compounds I have that have the same number of protons is A and C. And if you'll look, they also have different numbers of neutrons. So these are both the same element. They are just isotopes of that element. Question number 20 says of the 2 isotopes from question number 19, which one would be the heaviest? Well, they both have 13 protons. And the difference is that one has 12 neutrons and one has 14 neutrons, but they have the same number of electrons. So the only difference is neutrons. Well, so number A, or letter A, would be the heaviest because it has more particles. It has more neutrons in it. Number 21 says that when you burn fuel, what besides the fuel gets used up? We will actually spend a lot of time with these types of reactions in a later chapter. This is called the combustion reaction. And anytime you're burning something, you actually need oxygen. And oxygen gets used up. This is related to that magnesium oxide reaction that they talked about in the comprehension check questions when they talked about burning magnesium and it gaining mass because it's actually gaining the oxygen. And so when you burn fuel, you're also using up oxygen. Number 22 says, what particles do you find in the nucleus of an atom? We find 2 particles. We find the protons, which are positively charged, and we find the neutral neutrons are both found in the nucleus of an atom. You guys did a really great job on the chapter 2 review questions. I'll see you later for the chapter 3.